If there is any issues with my voice screen, you can let me know. Okay, today's session is regarding probability. So in this, we will discuss regarding the basic stuff of the probabilities. We'll discuss the probability on coins, letters and numbers, marbles, probability on dice, probability on cards, and probability on set theory. Okay, starting with a basic stuff here. So first thing, what is probability? Probability is nothing but its occurrence, how often the chances are being occurring, right? For example, let us say a coin is tossed. A coin is tossed. Coin will be having two faces. How many? What is the probability of occurring on head, occurring on tail? Okay, not only coin. So here we have we have to know about coin. We have to know about dice. We should know about cards also. Okay, we should know about how with the probability of a set theory. So set theory is completely different that we will discuss after discuss in the sequence first. First, let's start about the basic stuff. So, starting with the formula of probability, probability is nothing but the formula of probability. You all know that, right? So, formula is nothing but the required outcome, whatever the outcome we require, divided by the total outcome. Required outcome by total outcome, or we can also say that favorable outcome divided by total outcome, total favorable outcomes by total outcome, right? So this is also a formula for probability, or we can say that symbolically, if we represent P of E, it's nothing but N of E divided by N of S. Okay, so this is the formula what we will use for happening an event. So what will be the range of probability happening an event? The probability will be always lie in between the range of 0 to 1. Okay, so that is always it will lie in the range of 0 and 1. 0 and 1. Yeah, right. So 0 and 1, I think you know that whenever there is no chance or no hope of happening an event, no chance, no hope, then the probability of that particular thing will be 0. And when it is compulsorily happening, the probability of that will be 1. Okay. Next thing, the sum of probability will be always 1, right? As I think I have already discussed this stuff, even though I'll repeat. Okay, let us say there is an experiment happened and there are some outcomes. So there are some outcomes like P by 2 and P by 4 are the three outcomes from an experiment done. So whenever there are three outcomes here, then what will be the value of P? That may be the question. I repeat once again. Let us say a certain experiment has three outcomes: P, P by 2, and P by 4. What is P here? What is P? To know what is P, we should know the property, one property that we have in the probability, that the sum of all events are the sum of all outcomes in a probability will be always 1. The sum of all outcomes will be always 1. So P plus P by 2 plus P by 4 gives you the value 1. So by solving this easily, you can find out the value of P. That will be, yeah. So that will be 4P plus 2P plus P is equals to 4. So 5, 6, 7P is equals to 4. So P will be 4 by 7. Okay. Next. Next. Yeah. So whenever there is and, as I repeated in, I have told in the previous session, and is there, we will multiply, R is there, we will add. And specifies multiplication, R specifies addition. Okay. At least. So whenever the word at least is there, we will take a values from maximum, minimum to maximum. Whenever at least is there, we will take from minimum to maximum. Whenever at most is there, we will take the values from maximum to minimum. Minimum to max, at most, max to min. Okay. So whenever there is a question related to selecting something, so selection requires to apply the combination part. Selecting is always combination. So combination formula is NCR. NCR is n factorial by n minus r factorial into r factorial will be the formula for the combinations. So this is the basic stuff regarding the principles or important points related to the probability. Now let's discuss simple shortcuts to remember this. This will be applicable for any type of the question. Okay. So first of all, let us say the first basic things regarding the coin. So probability of coin. If I talk about coins, coin will be having how many faces? So coin has two faces, right? So coin has two faces. So whenever a coin is tossed, the question will be like, for example, let us say two coins are tossed. What is the probability of getting head on both sides? Two coins are tossed. Probability of getting head on both sides. What is the probability of getting head on both sides? So this is my question. So basic stuff, probability is nothing but required by total. Whatever I require and what is the total, we should look after. So whenever the coins question is there, the total outcome will be always. So whenever you want to find out the total outcome here, this will never change. So the things required may be changed sometimes in the question, but total outcome will never change. So it will be always face to the power number of coins. Face to the power number of coins. For example, let us say two coins are tossed. Then what will be the total outcome when two coins are tossed? Face to the power number of coins. Face is every coin will have two faces. How many coins are tossed? Two. So finally the total outcome will be 4. If three coins are tossed, what will be the total outcome? So 2 to the power 3. If four coins are tossed, 2 to the power 4. In this way, we will analyze the total outcome for the probability of coins whenever the coin stuff has been given. Okay. And now, as of the question here, I asked you to find out two coins are tossed. What will be the probability of getting head on both sides? Quick reply in the chat box. Reply in the chat box. Yes. Two coins are tossed. What will be the probability of getting head on both sides? Simple question. Exactly. Exactly. It's 1 by 4. Okay. So let us say two coins are tossed. So let us say these are the outcomes from that. So head and head, tail and tail, head and tail, and tail and head. So what is the question here? Probability of getting head on both sides. Both the coins should give you the head, reflect the head on both the coins. So that the condition suitable here is only one outcome, right? Only one outcome. Over how many outcomes? Total 4 outcomes. So this stuff is not necessarily to do for each and every question. Like sometimes the question will be 5 coins. So 5 coins in the sense, what will be the total outcome? 2 to the power 5. That means nearly 32 outcomes will be there in this case. So it's very highly impossible to rule out this stuff every time. Okay, right. So at that time, we will apply the combination concept. You know the combinations, right? If 5 coins are tossed, I'll give you a small example. Let us say 5 coins are tossed. And my question here is, what is the probability of getting at least 2 hits? Probability of getting at least 2 hits. What is the probability of getting at least 2 hits? So 5 coins are tossed. We know the total outcome will be face to the power number of coins. So face to the power number of coins is 32. This will be my total. So 50% finish. So rest of the 50% is to know my required outcome. So required outcome should be at least 2 heads. Among how many heads? 5 coins will be having 5 heads, right? So at least 2 heads in the sense, at least 2 heads, are 3 heads, are 4 heads, are 5 heads. Okay, 2 heads, are 3 heads, are 4 heads, are 5 heads. So among these 2 heads, how many 2 heads from how many heads? Total 5 heads, right? So 5 C2, R in the sense addition. 5C3 plus again 5C4 plus 5C5. By solving this conceptual this equation, you'll get the answer. Okay, by solving this, you'll get it. So 5C2, I have already given you the formula, NCR formula. By applying the combination part, this is how these are the conditions and these are the places where we will apply combination. Where it is not possible to list out the values, list out the outcomes in this manner. Okay, if there are number of coins are very large, like 5 coins, 6 coins in that way. So this is a good idea to go with. Right. Now, so this was the basic stuff regarding the coins. Now let's see what that it will be regarding the letters. So sometimes the question will be given in the form of word. One word will be given, and the question will be asked like, what is the probability of occurring the vowels together? For example, let us say I'm taking an example here as a word Bihar. So Bihar is a word given, right? So in this word, my question here is, what is the probability of occurring all the vowels together? What is the probability of occurring all the vowels together? This is my question. So there is a word called Bihar, and what is the probability of occurring all the vowels together? So to solve this type of questions, first of all, we have to look after how many vowels are there in the word. So as of now, I can figure out there are 2 vowels, right? So there are 2 vowels in the word. So just tie the vowels together in this pattern and write the consonant aside. So let us say B, H, R are the consonants. Okay. Now, we know that probability is nothing but required by total. So, required by total. Total is nothing but always, in the previous class also, I have told you that wherever the word is given, the arrangement of the word will be always word number of letters in the word factorial, right? So, how many letters are there in the word? That much factorial. So, total will be always number of letters in the word factorial. So how many letters are there in the word? The word contains 5 letters, so 5 factorial, yes. Required outcome, what should be my required outcome? How to figure out the required outcome? So first of all, you make a pattern here like 1, 2, 3 and 4. So 4 factorial into how many things are there inside this? That is 2 factorial. How many letters? So this, what the question here exactly is, so there are 2 letters. There are 2, vowels that should always come together. In how many ways we can place this vowel that it should be together? So B, H, R are the letters. I have to place I and A to be together. So what are how many spaces I can place? This is the first, this is the second, this is the third, and this is the fourth. So 4 spaces I can fill IR to be together, IA to be together. IA here, I can write IA here, I can write IA here, R I can write IA here. So how many possibilities? 4 possibilities, so 4 factorial. How many letters we have as vowels? 2 letters, so 2 factorial. 4 factorial into 2 factorial divided by 5 factorial. So total outcome will be always number of letters in a word factorial. Okay. Right. This is the basic stuff regarding the letters. Right. Next thing is regarding the probability of numbers. So whenever probability of numbers is such a thing that you all know, right? So let us say there are numbers from 1 to 100. The question here is, if any number is picked randomly from 1 to 100, what is the probability of getting perfect square? What is the probability of getting perfect square if a number is picked randomly from 1 to 100? This is my question. Anybody can answer me for this? If you have answer, please put it in the chat box. Yes. Any answer for my question? Then you can place it in the chat box. I repeat the question once again. Let us say there are 100 numbers, and you have to, if a number is picked randomly, what will be the probability of the number is to be a perfect square? What is the probability that the getting the number as a perfect square? Yes. Quick answers. So how many perfect squares from 1 to 100? what is my required and what is my total. I have to just concentrate on required value and total value. What will be the total? Total is nothing but how many numbers are there totally. For example, let us say there is a box. In this box, I have some chits. So all the chits are numbered from 1 to 100. So all the chits are numbered from 1 to 100 are placed in this box. If I pick one number outside, that number should be a perfect square. If I take one chit from here, that chit should be a perfect square number. What does it mean by perfect square? First of all, perfect square in the a number like 4, okay, 9, in this way. So 2 square, 3 square, 4 square, 5 square, all these numbers are perfect square, even 1 square also. Okay, so 1, 2, 3, 1 square, 2 square, 3 square, 5 square. In this way, how many perfect squares will be there totally? We need to count the perfect squares. Okay, so count of perfect squares from 1 to 100 will be 10. 10 perfect squares will be there. You can see that 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square, and 10 square. All these numbers are there in the box. Whatever that slip I am taking from the box, that is a perfect square. Then how many possibilities are there? The possibilities are 10 possibilities. From how many total? Total 100. So total is 100 because the box contains 100 chits. From 100 chits, 10 are my required outcome. So required outcome divided by total outcome will give you the probability of an event always. Is there anything that I have to repeat or anything you are unable to understand? Then you can always put a message in the chat box. Okay. Right. Is there anything that you have not understood this Bihar concept? I mean the letters, probability of letters concept, or anything regarding coins or anything regarding numbers and all this. You are always welcome to put your question here. So these are just Bihar once again. Sure. I expected that someone will ask. Right. See, the question here is probability of occurring all the vowels together. So the word may be anything. We should not worry about the word. We should worry about the number of letters in the word. So Bihar contains how many letters? 1, 2, 3, 4, 5 letters. So always the total outcome, whenever the word is given, total outcome will be always a number of letters in a word factorial. Number of letters in a word factorial will become your total outcome. I repeat once again. So probability is nothing but required by total. Simple. So I want my total, then total outcome whenever it is concerned with the words, then we should see that the number of letters in a word factorial. So how many numbers are there in the word? 5 numbers. So 5 factorial will be my total outcome. Now moving on to the required outcome. What I require my vowels to be together. In how many spaces I can arrange the vowels. So vowels are 2 vowels, tie up 2 vowels aside. So where I can put in the rest of the numbers, you write it in this way. B, Z, R are the rest of the numbers. I have to put these 2 letters always together. How many chances are there? So how many chances I will make a space? I will make a blank. So 1 chance, 2 chances, 3 chances, or 4 chances, or 4 possibilities, right? So 4 possibilities, 4 factorial into, we have to see how many letters are to be arranged here. 2 letters. So 2 factorial. So 4 factorial into 2 factorial divided by 5 factorial will be the final answer. If you solve this, you'll get the answer for that. I hope you understood the concept. Is that okay, Athiya? Right. Good. Okay. We'll move on to the next concept here. We have done with the first basic stuff. Next, moving with the marbles. Probability of marbles. So probability on marbles are balls, both are same. The question related to marbles or balls, whatever it may be, the pattern of doing the question will be the same. So here we should know the concept of repetition. and the concept of repetition not allowed. Repetition allowed and repetition not allowed. So first of all, a simple example. Let us say a bag contains 10 marbles. Okay, bag contains 10 marbles. From this 10, 5 marbles are blue, 5 are pink. If 2 marbles are to be picked randomly, we need to pick 2 marbles. 2 marbles are to be picked randomly. Are to be picked. Now my question here is, what is the probability that 2 are not pink? What is the probability that 2 marbles are not pink? Not pink. Mind my words. Not pink. Okay. Right. So this is my question. What is the probability that 2 marbles are not pink? So first of all, what we want? We want the probability. What is probability required by total? So what is my required? What I require here and what is my total? First see the total. How many marbles? Total 10 marbles. So what is the condition? The condition here is both the marbles are not pink. And the condition here, there is no condition that repetition allowed, repetition not allowed in the question, but we are making it both. Okay, whenever the repetition is allowed, what does it mean by repetition allowed? Let us take a box. Let us put all 5 blue balls and 5 pink balls in this box. I am picking one ball. Okay, if I pick one ball, one blue ball I am picking. So how many blue balls will be left in the box? 4 blue balls will be left. For first chance, for first time I am picking one blue ball. And for the second time, I am picking, not here we are talking about marbles, right? Yeah, first time I am picking one blue marble and second time I am picking one pink marble. Pink marble and a blue marble. So left with 4 and 4 again. What I'm doing after taking these two, I can see that these two I don't want. I again replace inside. I'll throw this two. I'll put all both the two balls again. Replace the balls inside the bag. The number of balls inside the ball will not change for the next outcome. Are you getting my point? If I replace, that means the number of the balls whichever are there inside the ball will not change for the second chance. But whenever I am not replacing, what I am doing, from the 5 balls, I am taking one ball and throwing off. Remaining are 4. Again, second time, whenever I pick, I will pick from 4. And for the third time, whenever I pick, I will pick from 3. Right? This is the concept of repetition allowed and repetition not allowed. So whenever repetition is allowed, how to do it? We have to pick 2 balls, right? 2 balls are to be selected randomly. So for the first selection, what will be the thing for the first selection? Let us say the question here is not pink. So I already told P of E is equals to required by total. This is the basic stuff. And not happening an event. P of E bar will be the not happening an event. That will be 1 minus P of E. So first of all, you find out P of E and then you can minus it. First, repetition is allowed. So repetition is allowed in the sense, what are the two things? 2 marbles are to be picked, 2 marbles are not pink. So 2 marbles to be pink is 5 by 10 and 5 by 10. So this is for repetition allowed. So repetition not allowed in the sense it will be 5 by 10 into 4 by 9. Okay, 5 by 10 into 4 by 9. So this will give you somewhere around 2 here and 5. So 10 by 5 ones, 5 4. 5 gets answers. So it will be 2 by 9. 2 by 9 will be the probability of event whenever the repetition is not allowed. Whenever the repetition is allowed, then 1, 2, 5 ones, 5 twos, it will be 1 by 4. Whenever repetition is not allowed, it will be 2 by 9. Now my question here is, we need to find out both the marbles are not pink. So 1 minus P of E. What is P of E in case of repetition allowed? So in case of repetition allowed, P of E is 1 by 4. It will become 4 minus 1 by 4. Okay. Sorry. Yes. So finally it will be 3 by 3 by 4. So repetition not allowed. So it will be 1 minus 2 by 9. Okay. 9 minus 2 by 9. That will be 7 by 9. I hope you understood the concept of repetition allowed and repetition not allowed. This is very important to understand. Okay. So if there is any problem in understanding, then you can let me know. I'll repeat once again. Yeah, 7 by 9 is correct answer, Sai Kumar. Okay. Right. So this was the stuff regarding the marbles or balls. Repetition allowed in the sense we will write the same value. So just a simple blind mark. If it is allowed, then we will repeat the same value. If it is not allowed, then we will deduct that. That's it. Next thing. So probability on marbles we are done with, and we will see what will be the probability on dice. Yes. Probability on dice. So die has how many faces? 6 faces, 6 numbers, right? So not faces here. We can say here die will be having 6 numbers on that. It consists of 6 numbers or 6 faces, whatever. So 6 faces. So whenever we are throwing a die, what will be the total outcome? So simple thing here also. Total outcome will be always face to the power number of dice. So faces are 6. If one die is thrown, then the total outcome will be 6 to the power number of dice. 6 to the power 1, that is 6. If 2 dice are thrown, 6 to the power 2, that will be 36. If 3 dice are thrown, what will be the total outcome? 6 to the power 3. In this way, we will take for the total outcome. Required, we have to see what are the requirements, what are the conditions given, and we will go through the requirement. For example, let us say a simple question here. If a die is thrown, what is the probability of getting a multiple of 3? If a die, only one die is thrown, what is the probability of getting multiple of 3? Quick reply in chat box. A die is thrown, what will be the probability of getting a multiple of 3? Die contains number 1, 2, 3, 4, 5, and 6, right? How many multiples of 3 are there here? So multiples of 3. How many multiples of 3? 1 and 2 multiples of 3, right? So the question answer for the question is 2 will be my required. What will be my total? 1 die is thrown face to the power number of dice. So 2 by 6. 1 by 3 will be the final answer. Okay, if 1 die is thrown. If 2 dice are thrown, then accordingly we will count the values of multiples of 3 from 2 dice and we will answer the part. Okay, so question will not be that much simple in the exam, right? So don't be in a mind that these are the things you'll be getting exactly. No, this is just a basic stuff. Okay, so let me tell you one simple question here. Let us say 2 dice are thrown. 2 dice are thrown. What will be the probability of getting the sum of the digits? Sum of the digits on both faces is 8. Sum of the digits on both faces is 8. This is my question. Yes. Take some time to answer this. Once you finish, put your answer in the chat. So I'm waiting for your answers. Yeah, 1 by 3 was correct for the previous one. Try to answer this. I repeat the question once again. Okay, a die is thrown. Sorry, 2 dice are thrown. Then what will be the probability of getting a sum of the digits on both faces is 8. Sum of the digits on both faces is 8. What is the probability for that? Yes, quick answer. 5 by 36. Very good. It's correct. So 36 will be my total outcome. You should not struggle for total outcome. It's very simple. Face to the power number of coins. Okay. So phases are 6 to the power 2, 36 will be our total outcome. We should struggle for only our required outcome. What are the required outcomes here? The condition here is on both phases it should be 8. The count of that, the sum of that will be 8. We should check what are the chances of getting 8. Sum of the two digits are 8. So 3 and 5 will give you 8. 2 and 6 will give you 8. 5 and 3, 6 and 2. Okay, again 4, 4. These are the cases will give you the 8. So 3, 5, 2, 6, 5, 3, 6, 2, 4, 4 will be sum of 8. So how many chances? 5 chances. So required 5, total 36. This will be the answer. Okay. Next thing here will be regarding probability on cards. Probability on cards. So whenever we are talking about cards, we should know the deck of card contains 52 cards. In a deck of cards, it contains 52 cards. So these 52 cards are divided into red cards and black cards. So here the red cards will be 26 red cards and 26 black cards will be there in the deck. So here if we talk about the red cards, again classified as heart and diamond. It will be 13, 13 here. Again black cards. So it will be, so black cards are also classified into 2, clubs and spades. So clubs are 13 and spades are also 13. Now, what are these 13 consist of? So 13 consist of 9 number cards. First 9 number cards and then 3 face cards, okay, and 1 special card. What are these 9 number cards? The number cards, numbering 9 number cards. And the next 3 face cards in the sense K, Q, and J are the face cards. Special card will be the ace card. Now, combinedly, these 2 cards are called as honor cards. So, this basic knowledge of the cards should be there in your mind. So, total, whatever the question it will be from the stuff, you should know how many heart cards, diamond cards, clubs, spades, and what are the honor cards. Honor card in the sense the face cards plus the special card gives you the honor cards. This is regarding the cards concept. The question will be anything, but the stuff should be there in your mind. Is there any query? Then you can always ask in the chat box regarding anything. Okay. So, important thing before going into the set theory concept, we will see some questions related to the whatever the discussion we have done till now. So, all the slides are representing whatever the slides are there in the PDF, PPT presentation here, representing the same stuff, whatever I have explained in the basic thing. Yes. This is the first question. Try to answer me for this. A number is randomly chosen from a list of 10 consecutive positive integers. What is the probability that the number is greater than the mean? So first of all, you should know what is the mean of 10 consecutive positive integers. Whenever we are talking about mean of consecutive integers, then we should always take the number, the last number plus first number divided by 2. Last number plus first number divided by 2 gives you the mean directly. So it will be 11 by 2, 5.5 will be the mean. What is the probability that the number is greater than mean? We have to see how many numbers are greater than 5.5. What will be the probability for this? Any answer? Quickly reply in the chat. Yeah. Reply for this. Required by total. Always put it as a blind mark. Required by total will be our probability. We are not worried of any complicated formulas, complicated terminologies. No need of anything like that. Just simple thing you put in a mind. Required by total. Okay. So what is the probability that number is greater than mean? So we have to see what are the numbers greater than mean. This is my mean. So what will be my total first of all? The total will be Usually we know that the total will be always the 10 consecutive numbers. The 10 will be my total. Okay, greater than 5. So if I take the number as 5.5 or 5 approximately, so 6, 7, 8, 9, 10 are the numbers which are greater than 5. So probability will be 5 by 10. So that will be 1 by 2. I have to count 1, 2, 3, 4, 5 numbers are greater than the mean here. So 5 divided by 10 will be 1 by 2, half of that. Next, a number is randomly chosen from first 100 positive integers. What is the probability that it is a multiple of 3? So from first 100 numbers, how many multiples of 3 will be there? How many multiples of 3 will be there? A simple trick, we have to see what is the last number which is a multiple of 3 from first 100. So 99 will be the multiple of 3, last number from first 100, right? Divided by 3. So 3 ones, 3 threes, 3 threes. That means there will be 33 numbers which are multiples of 3. Okay. Now required by total. Again comes with the basic stuff. Required by total. Required is 33. Total is 33 by 100. Okay. 1 by 2 was correct for the previous one. And this is 33 by 100. I know I am moving little faster because we have less time and many things are to be discussed. Okay. Right. An integer is randomly chosen from 2 to 20 inclusive. What is the probability that the number is prime? The same stuff, right? So you have to look after the prime numbers from 2 to 20. So all these you can do. We'll move to the important stuff here, the set theory concept. Probability on set theory. So first of all, what does it mean by set theory? Set theory in the sense, let us say how many types of sets we can say we can analyze. So sets, let us say there are two sets here. So the types of sets are like disjoint and overlapping. Disjoint sets and overlapping sets. So what does it mean by disjoint sets? Which don't have any common element from both the sets are disjoint sets. Whenever there is a common element from both the sets, it is called as overlapping set. Right? If I take A and B as sets here, disjoint in the sense where there are no common elements, overlapping in the sense when there are common elements included. Right? So disjoint in the sense always we will take it as no common elements that you know. So in this set theory of probability, you should know that what is sum and what is product. Sum is nothing but union. Sum is union and product will be intersection. Okay. Now there are two types of events which will be happening here in union. So what are that? Mutually exclusive events. What does it mean by mutually exclusive events? The events may not occur at the same time. We call it as mutually exclusive events. The events which doesn't occur at the same time. So next thing is mutually inexclusive events. Mutually inexclusive events in the sense events occur at the same time. I repeat once again, please make a note of it. Sum in the sense union. So union means wherever we have two concepts to discuss here, mutually exclusive events and mutually inexclusive events. Mutually exclusive events in the sense the events which not occur at the same time, and mutually inexclusive events in the sense events which occur at the same time. Now talking about the product of something, it is represented as intersection. So product is represented as intersection here. Now here we have two types of events, that is independent events and dependent events. What does it mean by independent? Independent in the sense the first event does not affect the second event is called independent event. And if we talk about the dependent event, the first event will affect the second event is dependent event. Now, how to deal with this? 1 second, I'll. Yes. So what are the formulas related to this stuff? So first of all, when we are talking about mutually exclusive events, we should always put in the mind that the formula of P of A union B. P of A union B, as I told you, it's sum. Sum in the sense P of A plus P of B. I'll give you an example also for this. Don't worry if you don't understand. I'll give you an example question so that you can put a framework in your mind. So what is that exactly? Okay, next thing, mutually inexclusive event, for that it will be P of A union B is equals to P of A plus P of B minus P of A intersection B. Now talking about independent events. So independent event is P of A intersection B. Intersection means product, right? So it is P of A into P of B. Dependent events. So dependent event is nothing but P of A intersection B. So that's nothing but P of A into P of B given by A. Okay, B given by A. I repeat the complete concept once again. Please concentrate on that. So set theory is an important thing in this probability, that you should always know about the differences of what type of questions will be asked here. So first of all, mutually exclusive event. Let us say the question here is, a box contains some marbles. Okay, so that is 6 red marbles are there. 6 red marbles and 7 blue marbles are there in a box. And a person need to select a marble. A person need to pick a marble. What will be the probability that the marble is either red or blue? Red or blue. Okay, R is plus. So one more thing you should know. R means plus. And means product. Red and blue product. Then we will take it as the concept here of independent events. So that is the difference exactly what you should go through the question. Okay. So next example thing for inexclusive events. What is the example for inexclusive event is, let us say a die is rolled, a die is thrown. It has sides of 1 to 9 numbers are there on a die. Okay, die has side numbering 1 to 9 is rolled. Then what is the probability of obtaining it an odd or prime? I repeat the question once again. Please make a note. A die is rolled which has numbered from 1 to 9. What is the probability of getting an odd or prime? Probability of getting an odd or prime. You know, prime numbers, except 2, all the numbers are odd numbers. So 2 will be the only even prime number in the complete set of prime numbers, right? So odd numbers are prime numbers. So that's the thing, we have given it a name, that it is a concept of mutually inexclusive event. I hope I am clear. Okay, so whenever mutually inexclusive event concept is there, then we have to go through the formula P of A union B, P of A plus P of B minus P of A intersection B. Clear? Right. Now moving about the independent events. So independent events, and you have to see is look for the question like and. So let us say a coin has been tossed, 3 coins are tossed. Okay, the probability of getting head in the first toss, head, probability of getting head on first toss, and probability of getting tail in second toss, and probability of getting head on third toss. What is the probability of getting head in first toss, second toss tail, and third toss head? So probability of getting an head, if one coin is tossed, head or tail, it is half, right? So half into half into half gives you the answer, and specifies multiplication. So simple basic thing you should never forget is and. And is for product, and product represents independent events and dependent events. Clear? Is there anything you have not understood in this complete set theory concept? You can put a message in chat box. If everything is clear, I'll move to the question part. Waiting for your reply in the chat box. If it's clear, put S. Good. Okay. Moving towards the question. So just make a note of all these four. P of A union B, that is union in the sense addition, P of A plus P of B. Mutually inexclusive event, P of A union B, that is P of A plus P of B minus P of A intersection B. So if it is independent event, P of A intersection B, that is the product of the both P of A into P of B. Okay. Dependent event, P of A into P of B given by A. Okay. Right. Moving on to the question type here. Yes. There is a question here on the screen. Try to find the answer for that. If the probability is half that the coin will turn head, on any given tosses, and the probability is 1 by 6 that the number cube will face numbered 1 to 6 with turn up any particular number, what is the probability of turning up a head and a 6? And head and a 6. Okay. I think you understood. What should we do with and here? Ready-made. Data is ready-madely given. Only thing is you have to extract the values and you have to put a mathematical operation in between. Yes. The probability is half that the coin will turn up head. And the probability is 1 by 6 that the number cube with face numbered 1 to 6 will turn up any particular number. So what is the probability of turning up a head and 6? Turning up a head and 6. So probability is half that a coin will turn up, right? So half. And second thing is 1 by 6 for the cube. It's already given. So 1 by 6 or cube will be having 6 faces. So 1 by 6. So basic stuff. We have already gone through the basics. So it's nothing but 1 by 12. The probability of that will be 1 by 12. Yes, it's 1 by 12. Good. Next question. Yes. The probability of rain is 1 by 6 for any given day next week. What is the chance it rain on both Monday and Tuesday? Monday and Tuesday. Yes, quick answer. The probability of rain is 1 by 6 for any given days next week. What is the chance it will rain on both Monday and Tuesday? Every day, the chance is 1 by 6. So on Monday, it will be 1 by 6. And Tuesday also, it will be 1 by 6. It will be 1 by 36. The probability of getting rain will be 1 by 36. Okay. Next. A six-sided cube has sides numbered 1 through 6. If the cube is rolled to 12, what is the already done? We have already done the probability of sum of two dice rolled equals to 8, right? The same thing. So that was something 5 divided by 36. 2 rolled, yeah, 5 by 36. It's done already. Yes, we will see some questions on marbles. So bag contains 3 red, 2 blue, and 7 white marbles. If a marble is chosen randomly from the bag, what is the probability that it is not blue? Not happening an event. What is the probability that it is not blue? Quick answer in the chat box. What are the things? The bag contains 3 red, 2 blue, and 7 white marbles, right? If a marble is chosen randomly from a bag, what is the probability that is not this? Okay. So from this, a marble has been chosen. We should know what we should know. The simple thing required by total. So what is our total? Total marbles. So 7, 9, 3. So it is 12. So total is 12. Required. What we require? We require that it should not blue. So first of all, we will see what is the probability of happening and blue. That is 2 by 12. 1 by 6 will be happening an event. So P of E is 1 by 6. P of not happening an event will be 1 minus 1 by 6. So that will be 6 minus 1 by 6, 5 by 6. This will be the answer. Okay, let's see how many of you have given the answers. Yes, Atya, correct. Okay. So not happening an event, always remember, if it is not happening an event, you have to subtract it from 1. Okay, 1 minus happening an event gives you the answer exactly. So first of all, you have to find out for probability of happening and subtract it from 1. 1 minus 1 minus 6. 1 minus 1 by 6. Next question. Yeah. 2 balls are drawn from a bag containing 5 white and 7 black balls at random. What is the probability that they would be of different colors? 2 balls are drawn from bag containing 5 white and 7 black balls. So 2 balls, right? 2 balls are being drawn here. So whenever the question is regarding more than one, I already suggested you to apply combination. Okay. So required by total. What will be the total? So total is nothing but how many balls are to be drawn? 2 balls are to be drawn from how many balls exactly? 5, 7. So 5 plus 7, 12. 12 C2 will be my total. Required. So what will be the required one? So required is one ball should be from white. So white are 5 balls and one ball and right. So and one ball should be from black. So black are 7 balls. 7C1. Okay. They would be of different colors. That's the reason 2 balls are different colors. So one from white and one from black. So 5C1 is 5, 5 into 7, 12C2. What is 12C2? So you can make it like this, 12 into 11 by 2, 2 ones 2, 6, 6 into 11, 66. 66. So it will be 35 by 66 will be the answer. Let me check whether you get the answer or not. If you get the answer, well and good. If not, I think you had understood this one. Yeah, 5 by 6. But why not 12? For what? For what? Why not 12? I didn't get your question exactly. Well, so we should not take one ball. No, if it is one, we will take 12. So it's 2 balls. We are drawing 2 balls at a time. And 2 balls should be of different colors. That's the reason we are taking the total R from overall 12. Total will be 12 and 2 balls are to be drawn from 12, 12C2. Selection. So combination concept was discussed yesterday. I told whenever there are 7 balls or anything and we have to select 2 from that. 2 balls from 7 balls. How to select 2 balls from 7 balls? 7C2 ways. In how many ways we can select? 7C2 ways we can select. Okay. If there are 12 balls, we need to pick 2 balls from 12 balls. In how many ways we can select? So 12 balls are there. Our marbles are balls. Same stuff. So 12 balls are there. We need to select 2 from that. 2 balls from 12. In how many ways we can select? 12C2 ways. Bas khatam. Okay. Did you get the point, Atya? Right. Next question. The bag contains 6 white and 4 black balls. 2 balls are drawn at random. Find the probability that there are of same colors. Yes. Try to understand the logic here. A bag contains 6 white and 4 black balls. 2 balls are drawn randomly. Find the probability that there are of same colors. There are of same colors. Should we a minute? Should we multiply or add? What is the concept we have to apply here? There are of same color. What should be my required? So total is always, so how many total number of balls? 6 plus 4, that is 6 plus 4 will be 10. 10 C2, 10 C2 will be my total. What is 10 C2? 10 into 9 divided by 2, 2 ones, 2 fives, so it will be 45. Total will be 45. What will be my required outcome? So if you want to find out the required outcome, it will be always what I require. It should be a same color, right? Same color. So it may be 6 white. It may be from 6 white, or it may be from 4 black. It may be from 6 white, or it may be from 4 white. R means addition. Okay. So by solving this thing, you'll get the answer. So what is this here? 6C2. What is 6C2? 6 into 5 by 2. 2 ones, 2 threes, 3 fives. So it will be 15 here. And what is 4C2? 4C2, 4 into 3 by 2. 2 ones, 2 twos, 3 twos, 6 here. So putting all this together, 15 plus 6 by 45. So 15 plus 6 is 21 by 45. So probability of happening an event here, it will be 21 by 45. So putting in the simplest form, according to the options, if options are given, it's very essential to make it in the simplest form. So it will be 7 divided by 15. So this will be the final answer for that. Okay, right. Correct, 7 by 15. This will be the last question for the day today. Okay, try to give me the answer for this. So probability of drawing 2 red balls in succession from a bag containing 4 red and 5 black balls, when ball that is drawn first is not replaced. Okay, there is no replacement of a ball. Whenever replacement or repetition is not allowed, the concept we have already discussed. Repetition not allowed. Quick answer in the chat box. This will be the last question, and rest of the things you can practice. Red balls in succession, in the sense continuously 2 red balls are to be drawn from a bag containing 4 red. Okay, the bag containing 4 red and 5 black balls, in the sense how many total balls are there in the bag? There are 9 total balls in a bag, right? Okay. So what is the condition here? When the ball is drawn, first is not repeated. So first ball is not repeated. So 2 times. First is not repeated. That's nothing but 4 by 9 into 3 by 8. 4 by 9 into 3 by 8. 3 ones, 3 threes. 4 ones, 4 twos. So finally the answer will be 1 by 6 for this. Okay. The answer for that will be 1 by 6. This was the last thing for the day today. So if you have anything that you didn't understood in this session, you can put a message in the chat box. If not, I consider that the class has been ended here.
Thank you, ma'am. Also, if anyone has any doubt, you can ask right now. Also, I've shared the link for tomorrow's webinar. Do join. Ma'am, Atya is asking, was this the last math class?
Yeah, this was the last class for a data analysis concept. Still, we have to go through arithmetic module and algebra module, right? So, admin will be updating you the next class details and all. Okay.
Okay. I hope your doubt is clear. Also, Himani and Sai, do you have any doubt? Or you can leave the class. Ma'am, Sai has asked a question.
Yeah, resources for practice questions. You can purchase a book if you want from the stall, or you can download from Google ETS official guide. Okay, official quantitative reasoning guide is available in the Google, but previous versions will be there. If you want, you can purchase the new version. Okay.
Okay, thank you, ma'am.
Yeah, thank you.